Boa tarde. My name is Ken Anthony and I'm from Australia, Australian Institute of Marine Science. First of all, I'd like to say that I'm extremely grateful for having been given the opportunity to come to Brazil and work with some excellent people in marine science. I'm standing here in front of the Coral Vivo mesocosm facility, which is a very innovative, ambitious and excellently designed facility that promises to deliver some research into the combined effects of climate change, water quality and ocean acidification. On that note, I'd like to start my talk, and I wish I could be here in person and meet everybody, but we have made the decision that I will come back next year and hopefully get that chance. My talk now is going to be about coral reefs, and the question I'm addressing is about the risks and the vulnerabilities to climate change and ocean acidification. Now, climate change has become one of the key topics of coral reefs globally. It's a global stressor. It comes as a nasty package of problems associated with carbon emissions. It leads to climate change, which means global warming. Global warming leads to coral bleaching. It leads to an increase in the strength of the storms, the severity of cyclones, which causes structural damage. It also leads to sea level rise. Now, that is what we have seen already in action, but one of the things that we haven't seen so much of, but that we have a good understanding of in terms of the theory and the experimental evidence, is ocean acidification. That is the direct chemical consequence of CO2 in the atmosphere. Now, climate change and ocean acidification and the associated effects on coral reefs, of course, come together with a bundle of other problems which are associated with things like water quality, overfishing, pollution, and a number of other human directly caused impacts at a local scale. In this talk, I'd like to go through and present to you some of the data, some of the models, some of the science coming out of Australia and other labs in the world to try and give us a picture of where this might be leading to. What are the risks that we're looking at in near future, and what are our options? What can we do? What can we do about it? I'd like to start with a story from my home country, which is Australia. Australia has got the biggest coral reef in the world, the Great Barrier Reef. It stretches 2,200 kilometers along the Queensland coast. It is the size of Japan. Now, we're very fortunate in Australia in that we have a very well-managed reef. A third of it is protected, and we don't have a commercial herbivore fishery, which means we don't catch fish that mow the lawns on reefs. We don't fish the fish that are almost safeguarding the health at a local scale. We still have the problem in front of us of climate change and ocean acidification. And I'll try and illustrate here how the problem can be modeled. In other words, I'm trying to turn the problem into a mathematical little exercise for you. I'm not going to show you equations, but what I'm showing you is the so-called seesaw. If I understand it well, in Brazilian it's called da gangorra. And it is really basically a balancing act between two sides. What we have on the left here is a coral reef that is well seated in a healthy state. What happens then when you apply disturbance to that reef is that you move it into a less desirable state. If it's a strong coral reef, if it has resistance, it'll take a lot of effort for that disturbance to destroy that reef, at least temporarily. The ability of that reef to be knocked over, so to speak, is also a function of that balancing point that gangorra is balancing on. After the disturbance, the reef might look very destroyed, but it can come back if all of its processes are intact, which means that if it can grow, if it can recruit, if it can live in those new conditions after the disturbance. it can come back to its original position and it still is a healthy reef. I'm going to try and take you through a little exercise of one of the most frequent, or one of the natural disturbances on coral reefs globally. Now, when you see this slide, you might say to yourself, Brazil is a lucky country, and yes, I agree. If you look at the east coast of Brazil here, there's only been one cyclone hitting the reefs there in recent history. If you go to Australia, you can see that more than 400 cyclones have crossed the Great Barrier Reef. Other places in the world, like the Caribbean, and especially in Southeast Asia and Japan, cyclones are a big problem. They come and go, they knock over reefs, and reefs will have to recover from those disturbances. In an era of climate change, that is a problem, because what we have normally seen as a natural phenomenon, cyclones, are now increasing in strength. On the Great Barrier Reef, in the last 5-6 years, we have seen a number of very strong cyclones which have had devastating effects on our coral reefs. The projections for the future is that the strength of cyclones is going to increase. So when we look into this century, we might have an increased strength, not frequency, but strength of the worst cyclones. Coral reefs will have to deal with that. What I've done here is run a little model, and I'm using the conceptual model of that gangora that I showed you before. And what this graph, or what this figure shows in the top is mortality from cyclones. So I'm basically running a projection into this century with cyclones as the only driver of mortality. And what you see down in the bottom is the response of the corals. It is over a 90-year period, so it's from 2010 to 2100. And what I've done here is assumed that the frequency of cyclones stays the same, but they double gradually in their severity. When there is a cyclone, it gets worse and worse. What you can see is at the end of the century, the reefs are still okay because they are resilient. There's no other stresses on this reef, it's just the cyclones that we're dealing with. So they recover in between the different events, which means when you look back at the century, it's been healthy reefs. Let's go back to Da Gangora and have a look at what happens when we add other stresses. First, we have the cyclones knocking the system down for a while, but what if the reef, before it has recovered, gets hit by a cyclone? So the devastation gets worse, and potentially the frequency of disturbance events will increase. In 1998, the world's coral reefs lost about 16% of their corals to coral bleaching. That was a direct effect of climate change. Some people can argue, or you can argue, that maybe this was natural. However, this was not seen at that scale ever before. Now, if bleaching happens on a regular scale, and we're looking into the future, and projections of models suggest that by the middle of this century, if we keep emitting carbon the way that we have in the recent past, we might get to a point where coral reefs start bleaching every year.